Now after the division algorithm, we discuss about what is the concept of pigeonhole and pigeon principles. Then after that one you can discuss the small theorem. Now before going to that, what is the pigeonhole principle? Pigeonhole principle is nothing but if m pigeons are assigned to the n pigeonholes, m pigeons are assigned n pigeonholes where m greater than n, then at least 2 pigeons must occupy the same pigeonhole, pigeonhole. For example, simple an example. For example, suppose in your mapping 9 pigeonhole is there, then 10 pigeons are is there. Now generally each and everyone can mapping each and every pigeonhole and pigeons. For example, here 9 pigeonhole is there, here 10 pigeons is there, each and everyone mapping, finally we get the remainder only 1 pigeons. That pigeon also mapping the any one pigeonholes occupying extra. Okay. So that concept will be the pigeonhole. For example, for you see that definition, m pigeons are assigned to n pigeonholes where m greater than n, then at least 2 pigeons must occupy in the same pigeonholes. For that, for extra 1 pigeon is that pigeon is occupy the already occupied the 1 pigeonhole, that pigeonhole is also occupied. That concept is the pigeonhole principle. Okay. Now after the pigeonhole principle, discuss of this small theorem. Okay, very simple theorem. See the statement of let theorem. Let a, b, c, alpha, beta be the any positive integers. A, comma, b, c are the positive integers. Then we have to prove the 3 different parts. If a given b and b given c, a given b and b given c, then a given c, a given b and b given c, then you got to put through a given c. Come to the second one. If a given b and a given c, then you got to prove a given alpha b plus beta c, Come to the third part. If a given b, then a given bc, then a given bc, a given b, then a given bc. See the proof. Number simple proof. See the proof. First part, if a given b, then b given c. Generally a given b equal to any positive integer. That positive integer can be written as some alpha. Okay. So write it as a given b equal to alpha a. Second one you can assumption beta. So b given c equal to beta into b. Mark it as equation number 1, equation number 2. Now take it equation number 2 from equation number 2. You can take it c equal to beta into, we know the value of b is nothing but your equation number 1. What is the equation number 1? Alpha into a. So beta into b is alpha into a. So that is c equal to alpha into beta into a. Now by the basic induction principle, you can write it as c equal to alpha into b into a, can be written as a given c. A given the c is that a given c. This is the first proof. Come to the second proof. A given b and a given c, then you have to prove a given of alpha b plus beta c. A given of alpha b plus beta c. Come to the second proof. If a given b generally equal to some another positive integer, so that is here also equal to first one condition is alpha, second one condition beta. So a given b equal to beta, b equal to alpha a given c equal to alpha beta. Now you have to prove a given a b plus beta c. That proof part you can take it, the corresponding proof part you can some assumption. So let take it, if the proof part denominator alpha b plus beta c, that value take in alpha b plus beta c. We know the value of b. What is the b? Alpha into a plus b into, we know the value of c, alpha into beta. So write it as alpha into beta. Now multiplying alpha into alpha, alpha square, beta into beta square. Both the term, commonwealth term will be a term is there. So alpha square plus beta square into a. Okay, alpha square plus beta square into a. Now by the induction principle method, so write it as alpha b plus beta c equal to, that can be write it as a given alpha b plus beta c, a given alpha b plus beta c. Now come to the third proof. What is the third proof? If a given b, then a given bc, a given b, then a given bc. Generally equal to, the condition is any positive integer either alpha or beta. First you can take it as alpha. A given b equal to alpha, so that is b equal to alpha, b equal to alpha. You got to prove a given bc. That part also you can take it to the proof part, take it to some assumption. So let us take it bc term. So bc equal to, write it as, we know the value of b, but the above condition b equal to alpha into a. So alpha a into c, that equal to alpha a into c, write it as the basic multiplication 1 into 2 into a into b into c, write it how to write a into b, a of b into c, the concept write it as alpha a into c. We know the, so alpha a into c. Now we know the value of that alpha into c any positive integer. Basically the alpha in the given condition is the b is an positive integer. So by induction principle method you can write it as bc equal to alpha c into a, write it as a given bc. Okay, very simple theorem. The theorem is nothing but a, b, c, take it any two integers, a given b and b given c, then you got to prove a given c. Then similarly a given b and a given c, you got to prove a given alpha b plus beta c. Then last one a given b, then you got to prove a given c. Okay. The remaining part, next class we can discuss about the theorem and the Pigeonhole Principle concept based on the small problems. Okay. Thank you.